Alright guys, today's goal here, understanding how to do absolute value equations and inequalities. So you got to make sure, pause and read up to example 4 because there's some vocab and things but didn't need to be included in the video. So, alright, let's take a look at this first one here though. It says solve for x. Absolute value of 5x plus 15 equals 100. What it means when you get equations is you have to set up two of them. Now, the biggest thing, and I'll talk about this in 1 minute, just let me finish writing this. Okay. Something I should have said before is, see how there's nothing outside of the absolute values on that side of the equation, then we're good to get rid of it. So you copy down the original minus the absolute values, and then you copy it down again, but instead of positive 100, it's negative 100. Because again, absolute value is the distance from 0. And on a number line, isn't positive 100 and negative 100 that same distance from 0? So there's going to produce two values that'll help us evaluate this equation. But now it's the same two steps. Subtract 15. So you get 5x equals 85. Divide by 5. You get x equals 17. Here, subtract the 15 again. This is what I mean by the same steps. You get 5x equals negative 115. Divide by 5. X equals negative 23. Okay, let's look at another example. Okay, so this one here looks slightly different. But here's the thing. Are there anything outside? No. So what you do is you keep it. Keep the first one the same. And again, the first time, you just copy it down minus the absolute values. Then the second one, you still keep the first one the same. Very crucial. But then watch what you have to do here. It's negative the whole thing. Okay? So let's go back to the first one here. I would subtract the 5x, add the 15, so you get x equals 30. Okay, now go over here, move over to the next one, distribute the negative out, so you get 5x plus 15 equals negative 6x plus 15. Subtract the 5x, subtract the 15, so you get 0 equals negative 11x. Divide by negative 11, you get x equals 0. Now, I should have mentioned this last time, but you should always plug the answers back in and check them. So if I plug in 30, I get 5 times 30 is 150. So this is what I'm doing. 5 times 30 plus 15. Absolute value equals 6 times 30 minus 15. Absolute value. So you get 150 plus 15 is 165. You get 180 minus 15 is 165. The absolute values equal each other. Check. You plug in 0, you're going to end up with absolute value of 15 equals absolute value negative 15. That is also true, so we're good. But you don't have to plug them in like that, but just mentally go through and do a check. Because it's possible one of them might not work. Okay? Alright, let's look at some more examples. Okay, so this is what I was talking about. See how this plus 8 is on the same side as the absolute value, but it's not inside the absolute value symbols? That means we got to get rid of this before we do anything. So subtract the 8. You get absolute value of 5x minus 3 equals 14. Now, see how we have isolated the absolute values to be by themselves. Meaning, everything on the left side is the absolute value only. We moved everything else over. So now we're ready to do the 5x minus 3 equals 14 and 5x minus 3 equals negative 14. Add the 3. Divide by the 5. You get 17 over 5. Add the 3. Divide by 5. You get negative 11 fifths. So go ahead and press pause and plug them in to make sure that that these would be correct. But here's the thing, the real thing I would do is maybe not necessarily the original, but I would plug this into here as long as you did this first step correctly. Okay? So let's move on to another example here. So again, make sure that you read through the rest because the examples were done for you in your notes. Okay? If they're not, just ask me in class. Okay? So now we're talking about inequalities instead of equations, but it's going to be a very, very similar process. The biggest thing is we have to be able to identify when it's less than or when it would be greater than, okay? So let's take a look at, it says, write with a possible positive number and negative number. Okay, so here's the thing. When it's less than, it's like an and statement, and if you remember and statements, it's like these where it says x is greater than negative 3 and less than 5. Okay? So when it's a less than, this is how you set these up. Now, again, double check. Is there anything on the same side of the inequality as the absolute value? No. So everything's inside of it, so we're good. So watch. Instead of setting up two separate, what we do is this. You set up the and statement. Add the 6. So you get negative 9 is less than x and less than 21. And then remember, we could write it like this. That's the interval notation. Or the set notation you could do. Like that. Okay? Just reviewing some things. Alright, let's take a look at a couple more examples of these. Okay, so see how here it's greater than? That means the or statement. So remember, less than equals and, greater than equals or. The or equal to doesn't matter. So double check. Is the absolute value by itself? Yes. So what we do, 3x minus 4, copy down the original. This is more like the equations one. We copy down the original. Now here's the tricky part you got to remember. Or. You still copy down this, and this does become negative 14. But what you also have to remember to do is flip the inequality. So instead of greater than, it becomes less than. Okay? But we still have the or. So now go through, add 4. Divide by 3, you get x greater than or equal to 6. Add the 4. Divide by the 3. So there we go. And then let's talk about these, because if we had to do interval notation here, this one, you start with the smaller, so x is less than negative 10 thirds. Remember, that would be negative infinity to negative 10 thirds. And it can equal it because it's less than or equal to. And then you say union 6 to positive infinity. And then the set notation would be you should always start with the smaller half. Okay? Let's take a look at another one. So again, the first thing here, what are we looking at? Are we looking at an and statement or an or statement? And remember, less than means and, greater than means or. Well, this is a less than, so it's an and. But see how the absolute value is not by itself? So what do we need to do first? Multiply by 10. Those cancel. You get absolute value of x plus 2 is less than or equal to 80. Now it's an and statement. So remember, that means you still copy down the original, but then it stays in the middle. Subtract the 2. You get negative 82 less than or equal to x and less than or equal to 78. Okay? So let's take a look at some more examples of these, see how they go. Alright. So we're looking at this one. We have less than, so it's the and, it's by itself. So it's a little weird because you see the negative here. So what we need to do is move it to the other side. So you get 6 less than 8 minus 7x less than negative 6. Okay, so we go to solve this. Subtract the 8. You get negative 2. Oh, forgot to subtract the 8 over here. Common mistake made. So it's going to be negative 14 divided by negative 7. So you get 2/7 is greater than x and greater than 2. Okay, so here's the thing. If we pick a number between these two values, isn't 1 a number between 2/7 and 2? But here's the thing. This looks very weird because can you be less than 2/7 and greater than 2? No. And if you just picked a number greater than 2 and picked in 3, you plug that in, can an absolute value ever be less than a negative number? No. So when you get something like this and you don't have any solutions, the answer is just no solution. Okay? So that's it for today, guys. We'll see you guys in class.